Good evening, my dear students. Now we are going to go forward in our science curriculum for Prep 2 students. Lesson today we will start to study and explain the second unit in our curriculum. The second unit in our curriculum is about matter and chemical reactions. So in our unit 2 science curriculum, we are going to study more about the matter and what is meant by chemical reactions, how chemical reactions take place, and what is the importance of the chemical reaction, and what is the essential role of chemical reactions in our life. So let's start our first lesson in Unit 2. Our first lesson is with the title of Chemical Reactions. And our lesson objectives by the end of our lesson today, the student will be able to understand the concept of chemical reactions and understand the mechanism of chemical reactions. Let's start by our lesson preparation for our session today. The figure here shows the change of the color of meat before and after cooking. This is a piece of meat before cooking, and this is how the piece of meat looks like after cooking it. So from this figure and in our lesson today, we are going to explore the ideas that help ourselves to answer the following questions. The first question here: why does the color and texture of meat change after cooking? What can you conclude from the smells that accompany the cooking process? Is cooking meat simply mixing components, or does it involve irreversible changes? And why? What is meant by irreversible changes? It means that the meat after cooking can be returned back to its shape and color and smell before cooking. This is called irreversible changes. From our previous study, we learned the difference between physical change and chemical change. Let's remember together what is meant by physical change and what is meant by chemical changes and what are the differences between them. A physical change is like the melting of ice, is a change in the state or the shape of a substance without change in its chemical composition, such as in this figure the ice melts and its state changes from the solid state to the liquid state. We can take the liquid water and put it into the freezer. It will change back to the ice. So this change is a reversible change or can be reversed to its original shape, which is the ice cube. This is called a physical change. So the physical change is a change in the state. We can change from solid state to liquid state. We can change the matter from the liquid state to the gaseous state, or the reverse from gaseous state to liquid, or from liquid to solid, or changing the shape without changing the chemical composition. All these processes are called physical changes. So there is no here any change in the chemical composition. The water still water in its two states, the ice, which is the liquid, the solid state of water, and the liquid water, the same chemical composition in both of them. What about the chemical change? The chemical change is a change that results in new substance. So in this figure, for example, we started by the wood, and while burning the wood turns to the form of charcoal or the coal. So the change here results in new substance with different chemical properties from those of the original substance. The original substance here is the wood, and the final results is the coal or the ash, which results from burning the wood. So this is one example of the chemical change. So the chemical change must involve the formation of new substance, so the coal cannot be returned back to its original structure, which is the wood. So this is called a chemical change. Now, what is a chemical reaction? Let's learn about the meaning of the chemical reaction. And how can we tell when it occurs, or how can we detect the occurrence of a chemical reaction? That we will learn in the coming slides. We now are going to learn about the concept of the chemical reaction. So we will need to do an activity, and some materials and tools will be used in this activity. Let's learn about these tools. Baking soda, which is actually the sodium bicarbonate. The sodium bicarbonate is the chemical name of the baking soda. Vinegar, which is the dilute acetic acid. This is the chemical name or the scientific name of the vinegar. Vinegar is the commercial name, while the dilute acetic acid is the chemical name. Balloon, and empty bottle, and a spoon. So these are the materials and tools that we are going to need to do our experiment. For our experiment, our first step is we will put 2 tablespoons here in the balloon of baking soda. So we will take 2 spoons of baking soda and carefully put it inside the balloon. The second step, we will put a quantity of vinegar here in the bottle. So we just put 2 tablespoons of baking soda in the balloon and some of vinegar in the bottle. The next step, we will secure the balloon opening here over the mouth of the bottle tightly. So we carefully secure the balloon on the opening of the mouth of bottle tightly, and take care not to spill any baking soda from the balloon. So the baking soda will be here, and carefully we will close tightly the mouth of the bottle with the opening of the balloon. What we will do next, let's see. The next step, we will lift carefully the balloon and let the baking soda fall into the vinegar. So when we lift up the balloon, the baking soda that we put it inside the balloon at the beginning of our experiment will fall into the vinegar below, as in our figure. What we will observe that we will talk about in the next slide. Also, we need to answer some questions. What happens to the balloon? We observed that the balloon filled with a gas, and there is effervescence inside the bottle here. Is a new substance formed? Yes, exactly. There is some new substance are formed, and this new substance are the carbon dioxide that evolves from the reaction between baking soda and vinegar and fill up the balloon. And here this effervescence is an evidence on the reaction between baking soda and vinegar. Is this change physical or chemical change? Let's think together. Why is change physical or chemical? Now we can discuss our conclusion about this experiment. From this experiment, we can conclude a chemical reaction occurs between baking soda, which is the sodium bicarbonate, and vinegar, which is the dilute acetic acid, causing effervescence, and this what we had observed inside the bottle, and the evolution of carbon dioxide gas, which filled the balloon and increase its volume. Now, what is meant by chemical reaction? Chemical reaction is defined as the process of breaking the bonds between atoms of the reacting substance, which are the reactants, and formation new bonds between atoms of the products, which are the produced substance. So the chemical reaction involves two main processes, which are bond breaking in the reactants and bond formation of the products. In our previous experiments, the reactants were the baking soda and vinegar, which have the chemical names sodium bicarbonate and acetic acid. So the reactants are, in our previous experiment, were the sodium bicarbonate and the acetic acid, in which the breaking bonds process was formed. The products here are mainly the carbon dioxide and another product. So these products, new bonds are formed between the atoms to produce these products. The chemical reaction occurs when reactants combine, decompose, or are placed by new reactants to form new products. During studying the chemical reactions, we will observe many types of chemical reactions. In some cases, the reactants combine together, so they directly combine and form a new product. In some cases, the reactants decompose to give new products. This is called decomposition reactions. And in other cases, the reactants replaced by new reactants to form new products. In this case, the reaction is called substitution reactions. So we are going to give examples for all these types of chemical reactions. And these reactions take place through breaking the bonds between the atoms of the reacting substance, which are called the reactants. The atoms are rearranged and combined, forming new bonds to form a new substance. The new substance are called the products that have different properties from the original substances. So the chemical reaction which results the new substance, which are called the products. The products are differ completely in their properties from the original substance, and that is why the chemical reaction causes a chemical change, because the chemical reaction results in the formation of a new substance completely different from the original substance. Now let's study this figure to learn more about the chemical reaction and to imagine what happens during a chemical reaction. The first part of the figure are the reactants before the reaction. This reaction is the reaction between methane and oxygen, in which methane is burned in oxygen. And the results from this reaction is carbon dioxide and water vapor. So at the beginning of the reaction, this is a molecule of methane, which is formed of carbon and 4 hydrogen atoms linked to the carbon atom with single covalent bonds, while these are 2 molecules of oxygen. Each molecule consists of 2 atoms linked together by a double covalent bond. The second part is the breaking down of the bonds between the atoms of reactants molecules. We have 3 molecules here, 1 molecule of methane and 2 molecules of oxygen. So the bonds starts to break down, as you can observe. The bond between the hydrogen atoms and carbon also the double covalent bonds between the molecules of water. So the bonds are break down, and then the formation of new bonds between the atoms of product molecules are formed to give the new products, which are carbon dioxide molecule and two molecules of water. So this figure shows the example of a chemical reaction in which we start by reactants that are completely different from the products, and of course involves bond breaking of the reactant molecules and bond formation to give the product molecules. Now let's evaluate our understanding. Our question is: classify the following changes into physical changes and chemical changes. Our first question is about dissolution of sugar in water. When we dissolve some sugar in water, is this classified as physical change or a chemical change? Let's discuss this example together. Is there any change happen to the sugar or to the water? No, there is no change in sugar molecules or water molecules. Is the result a new substance which is completely different from the original substance? No, the result is not a new substance, it's only sugar in water or sugary water. So this change is a physical change. Evaluate your understanding and classify the changes into physical and chemical change. And our question here is about the conversion of milk to yogurt. When milk converts to yogurt, it gives a completely different product from the original substance. So as milk changes completely, this is a chemical change. Evaluate your understanding and classify the following changes into physical and chemical changes. And combustion of wax. Combustion of wax, any combustion is a chemical change. So when you see a combustion in any example, combustion process is a chemical change, because any combustion process turns the original substance to a new substance that is completely different from the original substance. So when you see combustion process of any type of matter, this will lead to a completely different product from the original, and you can classify it at once as a chemical change. We're still in classifying the examples into physical changes and chemical changes, and in this case we will classify melting of wax. Melting process includes the change of a substance from its solid state to the liquid state. and we have learned that changing in states is a physical change because it doesn't involve any formation of new substance. It's still the original substance if it's solid or a liquid. So melting process doesn't include the change of the composition of the wax. It's only the change in its state from the solid state to the liquid state. Now, evaluate your understanding. Clarify the following changes into physical change and chemical change, and our example here, rusting of an iron nail. During rusting of an iron nail, iron reacts with oxygen in the air, forming the iron oxide, which is the rust or the oxide that gives the iron nail its reddish brown color, and the iron nail is completely changed from its shiny appearance to the rusting appearance, and so there is a chemical change here. So this is classified as a chemical change because the result is completely different from the original substance. Now we are going to classify another example, which is burning a piece of bread in the oven. Burning is the same process of combustion. It turns the reactant or the substance into new substance that is different completely from the original. So also the word burning means there is a chemical change takes place to the bread and make a new substance or create a new substance that is completely different from the original substance. Evaluate your understanding and classify to physical change and chemical change. Our question is about lime water turns milky when carbon dioxide gas passes through it. When carbon dioxide gas passes through lime water, it gives a new product which is completely different from the lime water, and formation of the white precipitate or white powder that turns the clear lime water milky. So it's a chemical change. Evaluate your understanding and classify into physical and chemical change. The color of universal indicator strip is changed when it's brought close to ammonia gas. Ammonia gas will react with the indicator and gives a new substance that changes the color. So in this case also the change here is a chemical change. Evaluate your understanding. What type of change occurs in each of the following and what is the reason? Our first photo is adding a quantity of vinegar to baking soda, And this is the same experiment that we have discussed in our session. This is completely chemical change and results in the formation of effervescence and evolving of carbon dioxide. So the reactants here are the vinegar and the baking soda, and the results or the product here is the carbon dioxide. So it's a chemical change. What is the type of change here? A moldy bread. We start with a fresh bread, and when the bread is left in humid air for a long time, the mold begins to turn the bread to a moldy bread by secreting enzymes that do a chemical reaction on the bread, turning it to this shape. So this is completely a chemical change because it results in the formation of a product which is completely different from the original. What about the fireworks? The fireworks are completely chemical change because the fireworks includes some of the ignited chemical materials that explode in the air, forming these bright colors. So fireworks are chemical changes. The following figure illustrates a chemical reaction. This figure illustrates a chemical reaction. Write the reaction equation. Let's study together this figure. In this figure, we observe two hydrogen molecules. Each one of them is formed of two hydrogen atoms linked together by single covalent bond and added to one oxygen molecule that is formed of two oxygen atoms linked together by double covalent bond. And at the end of this reaction, two water molecules are formed. Each one of them is consists of oxygen atom and linked to two hydrogen atoms by two single covalent bond. So let's write this equation together. H2, which is the hydrogen molecules, plus O2 gives 2H2O. So 2H2, which are the hydrogen molecules, two hydrogen molecules. O2, it's one oxygen molecule, and 2H2O, the two water molecules, results from this reaction. The second question, write the physical state of the reactants and the products. In case of hydrogen and oxygen, of course, they are gases, so they exist in the gaseous state. So the reactants here exist in the gaseous state, while after reacting together, it results into the formation of water, which exist as droplets of water at the end of the reaction. so it exists in the liquid state. This was our last question in our session today. Me, Mrs. Suhail Zaki, was with you today under the supervision of the Science Consultant Office at the Ministry of Education live stream platform. See you next session, inshallah.